this current series which we are going through, the series is titled as Advanced Data Structures and Algorithms, and the topic which we are on to presently is about the list, sequences and vectors. So, about the list and vectors we have covered in our previous lectures. Today we are going to look into what actually we mean by sequence containers and how this vectors and lists are actually related to this topic of sequence containers. So, when we drill down into this sequence containers, we find that we have a feature of C++ which is a standard template library, and under which we have gone through our topic of vectors and list also. So, this standard template library, more specifically in short form we call it as STL, that offers many data structures and not only data structures but algorithms in order to make your programming easier and more efficient. Many of the things, many of the functionalities we can say are available in the ready-made form inside your standard template library. So, when we talk about sequence, these are essential part of your standard template library, and they are there to provide a way in which the elements are stored in a particular order. Now, why are they kind of advantageous to many applications? Because they enable the access to the element. It could be random access or it could be sequential access. So, sequence containers are, we can say, essential parts of a standard template library in which we are going to store the elements, and then obviously those elements are to be kind of accessed. So, in C++ these sequence containers are stored to store elements in a particular order, and this order or this storage is going to provide efficient random access to the elements and allows the insertion and deletion of the elements at any position. So, whatever elements we have stored, we can access them and we can insert new elements and we can delete the elements also. As far as header files are concerned, in which your sequence containers specifically in C++ STL are defined, there are two header files. One is named as vector, another one is named as DQ, under which most of the sequence containers in C++ are defined. So, if we are going to use any of the sequence container, which sequence container I am talking about, I will be giving you a list of most commonly used sequence containers in a short while. So, if any commonly used sequence container we are going to use, we need to kind of include the file, either the file vector or the file DQ. Now, this sequence container, coming to the data type, what kind of data type are we going to store within this sequence container? As they are part of a standard template library, and templates are there to kind of facilitate you to store any data type. So, it could be an integer, it could be character or a string or any user defined data types for that matter. All these data types can be stored inside the sequence containers. These sequence containers can be implemented as dynamic arrays, linked list, or can be array of fixed size elements. So, here what I am talking about is basically these sequence containers are actually, we can say, are type of or similar to some abstract data types, and these abstract data types, when we go into the implementation details, these abstract data types can be implemented as dynamic arrays, or they can be implemented as linked list, could be a singly linked list or maybe a doubly linked list, or it could be an array of fixed sized element which cannot be which cannot be resized at the runtime. No, it is not only about the storage of these elements. Several functions are also provided within the sequence container along with sequence containers, and these functions are helpful in manipulating these elements. So, for example, if we want to access, if we want to insert, or if we want to delete, if we want to search, or if we want to even update the elements, there are different functions for which are available for these kinds of functionalities. Now sequence containers, when we talk about, there are some specific features which we should be kind of aware about. So let us try to explore the features of sequence containers. So the first feature is ordered storage. Ordered storage, when I am talking about, that means the sequence container should store the elements in a particular order, and this order is actually defined by their position in the container. So it could be 1 2 3 4 or 0 1 2 3 4, depends. Then it is also possible to insert and remove elements at any point, while also enabling the effective random access to the elements. So we can access the elements randomly, and we can insert or remove some particular elements, or we can say all elements, starting from the beginning one or to the ending one, or any element in between the middle. So this ordered storage is a feature of sequence container. Then as I told you that you can access any of the elements. So random access or effective random access for the elements is also provided, and access to any elements in the container directly without having to traverse through the entire container is also possible. And the simplest example of this is nothing but the array. So in array we can access any element present in that array with the help of index, and in this situation we need not to kind of traverse through the entire container. We traverse through the entire array. We will just be kind of accessing the required element on the basis of its index. Now here is also a feature which is available, not of course not in the arrays, but in other containers. If I am talking about, then that feature is nothing but dynamic size. So dynamic size, when I am talking about, that means these containers can be resized at any moment, and this resizing of container will allow either the addition of the kind of new element, or we can say or it could be removal of the items, depending upon your need. You can resize the container at any point of time, and this resizing will help you in either adding more elements or removing the elements which are already kind of inserted into the container. So size, you can resize your container on the runtime. Then there are, we can say, insertion and deletion are kind of much more efficient. Why I am saying this is because this will allow, or the sequence containers are allowing for efficient insertion and deletion of elements at any position in the container. So I have already told you, be it the beginning of beginning element, or it could be end element, or any element in between the middle, all the elements can be effectively accessed, and if they are if we are able to access them, we will be also able to kind of insert and delete the element at any position in the container. Now this is possible because we are implementing the some of these sequence containers as dynamic arrays also, and in dynamic arrays we are able to kind of access these elements, or we are able to kind of resize the container itself. Now when we talk about sequence containers as a collective unit, this sequence container is going to provide a standardized interface for manipulating the elements. Now standardized interface for manipulating the elements means there is a specific set of functions, and that same set of functions is available for all the sequence containers regardless of the type which you are using. Then same set of functions is used to manipulate the elements. So we have a standardized interface, that means a set of functions which are there to access and manipulate the elements, and these functions will be available to all the sequence container regardless of the type of the sequence container being used. So whether we are using a list, or we are using a vector, or we are using any other sequence containers, some standardized functions are available which will go with all the sequence containers. Now, when we talk about which of the sequence containers I am talking about, there are basically various type of sequence containers available in C++. Each container is having its own features, own set of characteristics, or we can say each container is having its own advantages and disadvantages. Here I am going to list some of the popular containers which are available in C++. Please make sure that the list is not exhaustive. These are only the prominent or the most popular sequence containers which are there available in as a part of a standard template library of C++. So in this type of sequence containers, let us take the first one, which is nothing but vector. Vector, we are familiar, kind of we can say we are familiar with this term vector a lot, because we have studied this vector in a quite a greater length of detail. So vector, basically a sequence container providing efficient random access to the element. It is implemented as a dynamic array. Dynamic array, when I am talking about, that means it can be resized dynamically, or the size can be changed dynamically. Now vectors are efficient for adding or deleting elements at the end of the container, because some functions are available which will enable a vector sequence container to add or delete elements at the end of the container, or maybe we can say at the beginning of the container. So whatever types of the sequence container we are going to explore, each and every type is having its own utility or having its own application area in which they should be used in order to get the maximum we can say advantages or benefits. So vectors are efficient for adding or deleting elements at the end of the container. We have seen vector, as I have told you already. We have seen vectors in a kind of detailed length. I am coming to the next sequence container type, which is nothing but DQ. DQ, when we pronounce this term DQ, which is DEQUE, this is a short for doubly ended Q. Please do not get confused between the pronunciation, because this DQ is exactly pronounced as the deletion operation in a queue, which is DQ. So this DQ, when I am talking about, it is the short form of the doubly ANDed Q. Now this DQ is a sequence container that provides the again random access to the elements similar to that of a vector. It is implemented as a sequence of fixed size arrays, which allows for efficient insertion and deletion of elements at the beginning or at the end of the container. So DQ is actually a sequence or a sequence container implemented as a fixed size array, allowing effective insertion and deletion of the element at the specific positions, that is the beginning or end of the container. So if you are looking for some of the application usage which are going to require this type of scenario, you are free to use DQ. Various functions related to DQ are already available in STL. So we will be exploring those functions as well. Now we have seen vectors, we have seen DQ. Now coming to the third sequence container type, which is nothing but list. Now list is also a term which is kind of very familiar to us. I am here list, when I am talking about, specifically I am talking about the list in as a part of your standard template library in C++. So list actually implemented with the help of a doubly linked list. So that means we can move in the forward direction, and then we can move in the backward direction also. this list, which is list as a sequence container, offers the effective element insertion and deletion at any position in the container, but it does not provide random access to the elements, because I hope you understand, if the underlying data structure is of a type of a doubly linked list, then insertion and deletion at any position can be kind of done effectively if you have the access, but random access to the elements, that means jumping to the fourth element without traversing the previous three ones, is kind of not feasible here. So, your list will offer effective insertion and deletion at any position after accessing the position obviously, and this we have seen in our lectures which were about the list, but it does not provide random access to the elements. So, sequential access to the elements will kind of obviously will be provided. The next type of sequence container in the list is nothing but the forward list. So, when I am saying forward list and when I am saying list, the basic difference between the two is the list is implemented as a doubly linked list, while your forward list is a sequence container that is implemented as a singly linked list. So, when I am saying forward list, that means you will be moving in the forward direction only. There are no pointers to get to access the elements prior to the current element. And your forward list offers effective element insertion and deletion at any position in the container, but similarly it does not provide random access to the elements. But please remember, this effective insertion and deletion has to be in the kind of a forward direction. If I am talking about the backward direction, or if I am talking about the random access to the elements, then it is certainly not kind of very feasible inside this forward list. Coming in the sequence of this, coming in the list of this sequence containers, we have next, which is array. Now, array is a term which is very familiar even to for a kind of beginner of the programming thing. Array basically is a sequence container implemented as a fixed size 1. So, array is here is a fixed size, that means the size of the array is fixed at the compile time, you cannot change it dynamically. In order to change it dynamically, you cannot use array, you need to kind of use any other sequence container which will provide you this facility of resizing dynamically, which is not available in array because the size is being fixed at the compile time, and that is a mandatory requirement with the array. But the best thing is you can access the elements in a random manner just by knowing their index, and it is kind of an kind of a continuous arrangement. So, accessing the elements just by using their index is an easier idea. Another sequence container is also a very familiar term, which is string. So, string is also a sequence container that is used to store a group of characters, I can say, or a string of characters. It provides efficient random access to the characters because again these characters can be accessed with the help of index, and it also provides many functions for manipulating those strings. So, string manipulation, when I am talking about, will have kind of trimming that string, for searching substrings within a particular string, or if we want to append something to already available string, or if we want to concat the two strings. All these functions are basically very kind of common functionalities which are required with your string data types. So, this string container provides efficient random access to its elements, which are nothing but characters, and it also provides many functions for manipulation of strings and various functionalities of strings. Moving forward with this list of sequence containers, we have one more commonly used sequence container, which is span. This is basically used to represent a view of continuous sequence of elements, and it provides a known owning view of underlying container. Now, span is actually kind of, we can say, a little uncommon as compared to the other previous one sequence containers which we have seen, but this also allows for efficient manipulation of the elements. So, here till this point what we have seen is about your sequence container, what are these sequence container, what are the types of sequence containers, and couple of them like vectors and lists we have already covered in kind of we have already covered in detail. Now, when we started with this sequence container, I told you that each sequence containers provide a set of functions for manipulating elements, and these functions are standardized across all these sequence container. That means you can use the similar functions to manipulate elements of the sequence container regardless of which sequence container we are using. So, we will quickly look into some of the more general used functions for sequence containers. So, first is insert, and detail of these functions we have already seen in our lectures, details corresponding to the list sequence container and the vector sequence container, or the usage for list and vectors we have already explored. Insert, as the name indicates, it is used to insert elements at a specified position in the container. Then we have erase, to remove the components from the container from a particular location. Then we have push back for adding the element to the end of the container. Then we have pop back, which is the reverse of the push back, for removal of the last element from the container. Then we have the function size, used to determine the size of the container, or basically number of elements present in the container. Then we have clear. Clear function will delete all the contents of the container, and after this the container will become empty. Then we have begin. So, begin is used when we need an iterator, which is kind of a head or we can say it's a moving facility, or it's a pointer to the we can say that it's kind of a pointer to various elements. So, an iterator can be brought to the containers beginning using the function begin. If we want to place the iterator to the containers, and the procedure which will be which we will be using will be end. Then we have the function front, which is used to get a reference to the first element of the container, and corresponding to this front we have the function back, which is used to get a reference or pointer to the last element in this last element in any container. So, in order to summarize this lecture, we have started with sequence container. What is this sequence container? How they serve as a part of standard template library? What are different types of sequence containers, and what are the different standardized functions which are used for kind of playing around with these containers, or programming some functionality using these containers. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed one. I will see you in the next one. Till then, take care. Goodbye.